Okay, for today, we are still technically at the end of 9.2, which is about series and sequences of numbers. So let's say we had this from 1 to infinity, that you were going to do 4 is your starting number, times your rate, which is, let's say, 1/2 to the n minus 1. That's the general format that you'd use for a geometric. Okay? Now, on this case, can you actually add all of these up? Yes, because what rule has to be in place? What does it have to satisfy, or it won't work? Close R. R has to be between 0 and 1, but I just have figured out that technically you can have a negative rate and it'll still work. So you want your rate to be between -1 and 1. It's pretty close to between 0 and 1. But the point is you can have negative rates. And I've got a good example for you of using a negative rate. Okay? So this one we can do with this other formula because its rate is less than 1 is the main thing you got to worry about. It's not often you hit negative rates, but I'll talk about those in a minute. All right, so would you please use the formula? There's no formula on the board, but there is a formula for finding infinite series. Technically, the infinite series part is going to start after break, but I've gotten you into it a little bit early. Do you remember the sum of an infinite series is what over what? A over 1 minus r. And what's our A, our starting term? AO, like amount original. It is 4. And then it's divided by 1 minus r, and the r in this case is what? 1/2. So then it's really 4 over 1 minus 1/2 is 1/2, and then 4 over 1/2 is what? 4 times 2, which is 8. So the sum of all of those terms, which would be things like 4, and then half of 4, which is 2, and then half of 2, which is 1. Half of 1 is 1/2. You just keep adding those up, and you add them forever, you'll get 8. That's what's happening there, is that's an infinite series. Okay? All right, so let me use that idea to say, if I was 2 meters from the door, what I want you to do is make a list for me. Okay? Right now, you're just making a list. This plus this plus this. Okay. If I'm 2 meters from the door, you don't write down a 2. What I'm going to ask you to add up is, as I walk to the door, how far have I gone so far? Would you agree that if I start 2 meters from the door, like as the kids in class can see, I'm standing about 6 feet away, or about 2 meters from the door. If I go halfway, how far have I gone? 1 meter. Write down 1. Plus, I'm going to walk further. Now, if I go half of that distance, how far am I going now? That'll be 1/2. So it's 1 plus 1/2. Plus, you writing this list? What's the next distance? 1/4 of a meter. Plus, you get the idea? Now, I'd like you to write me one of these for that. So to get out the door, I started 2 meters from the door so that when I went halfway, my first distance I went was 1 meter. Plus then I went 1/2 a meter. Plus then I went 1/4 of a meter. So you should be able to make me one of these guys for that. Brooke. What's down here? To up here? Good. And then it starts with a what? I did not. There we go. I didn't start by going 2 meters, or I would have already been out the door, problem over with. You get what I'm saying? So we start with a 1 times 1/2 to the n minus 1. Excellent. Now, is this the kind that we can do? Is its rate less than 1? Okay, good. So we should be able to do this with the S, the sum. Everybody figure that out. What is the sum of all those things? 1 plus a half plus a fourth plus. Tell me how to do it.
So you put it, so 1 over 1 minus 1 half. You get half.
1 over. Okay. And you get 2. And does that make sense? You're 2 meters away from the door. If you add up all those halves, you're going to get 2. All these little parts are going to add up to a total of 2. That way I can get to the door. But see, if people argue it this way, if they say, well, you'll never get out the door because you got to go halfway to the door, and that takes some amount of time. And then you got to go half of that, and that's going to take some amount of time. And then you got to go half of that, and that's going to take some amount of time. And you're going to keep doing that infinitely, right? So isn't it true that at the end you still have to go some amount? No, eventually, here's the thing that messes people up. They remember the part about infinity that says you have an infinite number of things to add. But they forget about the thing about infinity is that we can do it infinitely fast.
So you just do each 1 half as, well, twice as fast as you do the first.
That's another way to think of it, yes. Incredibly fast at the end to go a tiny distance, right? Like a micrometer. Okay, so if that speed kind of approaches infinity also. I'll pause the video for a second. Okay, we're back from the pause there. And I'm sorry, I kind of lost my train of thought with all the interruptions. So I'm going to just summarize by saying that you can add up an infinite series as long as your R term is less than 1. Technically, it has to be between -1 and +1. All right, so now I'm going to go and talk about a paper folding activity that we have here. If you fold your piece of paper right, you can make one of these. I know you can't see that at home, but it's kind of cool. And it's sort of like a math snowflake, I guess you'd say. And so here's what you do. At first, you are just cutting out. You're taking this full piece of paper, and then you're folding it in half. Okay? You had a full piece of paper, and then we fold it in half like this. Now, all these pieces can go up like this. And so there, I just have half my piece of paper, right? And then I take half of that, but I do it in a special way by making a cut like this so that my half a piece of paper, after it's folded over in half, I kind of folded it this way. Anyway, I'm going to now cut right here and cut right here. And I'm going to make this distance be halfway to here. Like from here to here, I'm going to make it halfway. Now, if you by accident cut a little too far, you can actually save yourself by just folding this middle piece right. So once I've got the middle piece folded down here, see if I can get just the middle piece to fold down, it looks like this. Does that seem doable to you? Okay, it doesn't seem that hard, but you'd be amazed. And don't cut this out right here, okay? But when you fold this piece right here inside, you end up with, well, how much do you end up with? That's kind of the question. When it's an infinite series. Do you get I am decreasing how much area you can see of my piece of paper? Okay? So then if we consider the original one to be a whole, like my piece of paper starts this way. I know I already folded my piece of paper in half, and then we could do the problem based on that, but okay, set it away. Okay, focus on this. All right, so if I were to take out this much, I am getting a smaller and smaller amount. Do you get, I took out half of the piece of paper when I fold it in half, and then I took out, notice that's negative, a fourth of the piece of paper as I did my next cut. To get this right in here is a fourth of. Okay. All right, then if I keep that series going, what's different about this series than what we normally do? It's subtracting. And we're getting less and less of a piece of paper that's visible when it's all done. Now, for those that are at home, I wish I could show you this, but it would be really complicated to do that, so I'm not going to. But when I get this all folded up, you can kind of tell that you've taken out, can you guys tell you've taken out more than, I shouldn't say it that way. You've taken out less than half of the piece of paper. Can you tell that there's more than half like visible as far as the totals? All right, so let's think of it as if I had gone exactly from corner to corner and cut my paper like this, do you get by doing that, I'd be taking out half of the piece of paper? Okay, well this, when it's done, and I'll fold it up cool, kind of looks, it's got this jaggedy edge here, and it goes down like that. And these pieces here, when you're all done, add up to 2/3 of the total that we started with. So here's my question. If this thing adds up to 2/3, what must have been in my formula, S equals 1 being, again, I'm kind of cheating. I'm saying my half a sheet of paper is my 1 whole. Okay, that my whole piece of paper got cut down each time I did a cut. And it was less and less. 1 minus a rate. What rate must have to be here so that when it's all done, I have 2/3 showing. This is 2/3. Here's another way to say it. This red part is the part that's missing. That's about 1/3. In fact, it's exactly 1/3 if you did it perfectly of what I had to start with. All right, so really it's this equation. I don't know what this is, so what could I put there? Solve for x. Everybody, right now. What do you think? Okay.
Well, I thought it was
1 minus 1/2? You're close. Yes? Negative 1/2. Do you get how if we go 1 minus negative 1/2, it's like saying 1 plus a half? So if we just solve this out the normal way, you just multiply both sides by 1 minus x, and this side would cancel, and this would become a 1 minus x over here. Then we multiply both sides by 3, and this becomes a 3, and then the 3 here cancels off with that. So I have 3 equals 2 times 1 minus x. Now I'm going to multiply it all out, and I end up with, dividing by 2 on both sides, 3 over 2 equals 1 minus x. And so therefore, I have to say, let me think, I'm going to subtract 1 from both sides. So 1.5, and it'll be negative a half is, or positive a half is equal to negative x, and therefore x is equal to negative 1/2. Okay, so that means my rate had to be negative a half. Does it make sense? I was losing half each time I did that, half of what was left. All right, so anyway, that is giving you a physical representation that, again, I can't show on my video, I apologize, of what it looks like to take an infinite series and do it to paper. So I'm going to give you some paper and give you a shot at this. Anybody who would like to take the top 20, I'd be happy to have you take the top 20 during this time. If you would like to do the paper activity, I think unfortunately it's going to be one or the other because you probably won't have time to do the top 20 and the paper. Now if you finish the top 20, feel free to grab the paper. I'll show you how to do it. You always start by folding it in half, and then you cut in about 1/4 of the way in both directions. I'll show you how to do that if you're not taking the top 20. All right, so that's all I have for you for today. It's just a little activity day. I am not, and enjoy this because it's rare, assigning anything over the long break. You can just not think about math.